Welcome back to Technological Frontiers, one breakthrough at a time. Today we're doing a deep dive
Oh, cool.
into Game On, smart AI agents with reinforcement learning.
Interesting.
It's by Himmat Joel. He's a technologist who loves exploring, all the latest advancements in technology.
Sounds right up our alley.
Absolutely. And you should check out his full article. We'll link it in the show notes.
Yeah, definitely.
But get this. We're talking about using video games,
Oh,
specifically Doom, as a training ground for AI.
whoa. Hold on.
Yeah.
AI playing Doom.
AI that learns through experience, just like you and me.
So, like, it actually gets better as it plays.
Exactly.
That's wild.
It's a really clever approach. I mean, using something as familiar as video games to illustrate this complex concept.
Yeah, for sure.
Joel starts off with this quote from Confucius.
Oh, I love Confucius.
Yeah, me too.
Yeah.
I hear and I forget. I see and I remember. I do and I understand.
Wow.
Right?
It's like he's laying out the roadmap for how we learn.
And how AI can learn too.
It really is. It's a great analogy.
Yeah.
For the different stages of machine learning.
So the AI, it hears
Okay.
by receiving data. It sees by processing that data.
Uh-huh.
But the real learning,
Right.
the understanding, comes from the doing part.
That's where reinforcement learning comes in?
Reinforcement learning, or RL.
RL.
So RL is all about learning by doing.
Gotcha.
But why video games?
Yeah.
I love a good video game session.
Yeah.
But what makes them such a perfect fit for training AI?
Well, games like Doom offer a few key advantages.
Okay, I'm listening.
First, they provide incredibly complex and interactive environments.
Okay, so think about it. The AI has to navigate a 3D world, make decisions in real time, react to unexpected events.
Yeah,
That's so much closer to the real world than, say, a static data set.
it really is.
So the AI is forced to think on its feet,
Yeah,
just like it would in a real-world situation.
exactly. And the second advantage
Okay.
is that games provide immediate feedback. Every action the AI takes has a consequence,
Oh, interesting.
good or bad. This feedback loop is crucial for reinforcement learning
How so?
because it tells the AI what works and what doesn't.
Okay, that makes sense.
Succeed and you get rewarded. Fail and
Yeah, you know what happens in Doom,
exactly.
right? No respawns in real life.
Huh?
So games like Doom,
Yeah.
they essentially create this high-stakes learning environment where the AI is constantly being challenged and pushed to improve.
Precisely. And that's why they're such a powerful tool
I see.
for developing and testing reinforcement learning algorithms.
But here's what surprises me. RL isn't exactly a brand new concept, is it?
You're absolutely right.
Like, I feel like we've been hearing about it for a while.
Yeah, while it's gaining a lot of attention now, the foundations of RL have been around for decades.
Really?
In fact, Joyle mentions Richard S. Sutton,
Okay.
who's considered a pioneer in the field, and whose work dates back to the 1960s.
Wow. So this isn't just some flash-in-the-pan trend.
Yeah.
There's a rich history of research behind it. That makes its potential even more exciting.
It really does.
Absolutely. And the potential applications of RL are vast. Gil gives several examples in his article, from self-driving cars navigating complex traffic scenarios
Wow.
to robots performing intricate tasks in manufacturing.
Oh, cool.
We're even seeing RL being used to improve customer interactions in business.
Really?
Yeah, he mentioned something called next best action.
What's that all about?
It's essentially using RL to predict the optimal action to take in a given customer interaction.
Hmm.
So let's say you're on a website and you're browsing products.
Okay.
A system using RL could analyze your behavior
Uh-huh.
and predict what you're most likely to do next, then suggest the most relevant product or offer.
Oh, that's interesting.
It's about creating a more personalized
All right.
and effective customer experience.
Makes sense.
Wow. So RL is not only shaping the future of things like robotics and transportation,
Hmm.
but also influencing how businesses interact with us on a daily basis.
That's right. And we're only just scratching the surface of what's possible with RL.
That's crazy. Now that we understand why games are such a great training ground for AI, let's get into the details of Joyle's Doom experiment. He talks about setting up this whole Doom environment using something called Gymnasium.
Gymnasium.
What exactly is that?
Well, think of Gymnasium as a standardized toolkit
Okay.
for building and running reinforcement learning experiments.
Huh.
It provides a consistent interface for
Mhm.
connecting different algorithms,
Mm.
environments, and agents.
So it makes it easier for researchers to compare and share their work.
Exactly.
So it's like a common language
Yeah.
that everyone in the RL world can understand.
That's a great way to put it. It helps streamline the research and development process.
Okay, so Joel uses Gymnasium to set up his Doom environment. But how does the AI actually see the game? He
Hmm.
mentions VizDoom. What's that all about?
Well, Vizdoom is like the bridge between the game and the AI.
Okay.
It basically allows the AI to perceive the game's visuals, understand its surroundings, and react to what it sees.
So is it like giving the AI a set of eyes?
Yeah, that's a great way to put it. Vizdoom processes the raw pixels from the game screen
Okay.
and converts them into a format that the AI can understand.
Okay, so the AI can see the game thanks to VizDoom,
Hmm?
but how does it actually learn to play? That's where this whole PPO algorithm comes in, right?
Right.
Joel mentions it, but it sounds pretty complex.
It is a complex algorithm, but let me try to break it down. PPO stands for Proximal Policy Optimization, in simple terms. It's a type of reinforcement learning algorithm
Okay.
that helps the AI learn by trial and error.
So like how we were talking about before?
Yeah, remember the reward system we talked about earlier?
Uh-huh.
PPO uses that feedback
Okay.
to adjust the AI's policy, which
Policy.
is basically a set of rules
Okay.
that determines what actions to take
Got it.
in different situations.
So if the AI takes an action that leads to a reward,
Yeah.
PPO reinforces that behavior.
Hmm.
And if it takes an action that leads to a negative consequence,
Right.
PPO tries to discourage that behavior.
Exactly. It's like a continuous feedback loop
I see.
where the AI is constantly learning and refining its strategy
Yeah.
based on the rewards it receives.
And Juliel actually shows what this looks like in practice, right? He compares the AI's performance before and after training.
He does. And the difference is striking.
Okay, so walk me through this. What's the AI like before training?
Before training, it's basically a complete novice.
Oh.
It stumbles around the environment, gets
Yeah.
stuck, wastes ammo, and doesn't really stand a chance against the enemies.
So like watching someone play Dune for the very first time, a
Exactly.
lot of button mashing,
Uh-huh. Yeah.
and not much success.
Not much success at all.
So it's essentially making random decisions,
Right.
not really understanding the game or how to play it effectively.
It hasn't developed any strategies or learned how to react to different situations yet.
And then after training,
After training, it's a complete transformation. The AI is navigating the environment purposefully, taking down enemies efficiently, and even demonstrating learned strategies,
like what?
like dodging attacks and conserving ammo.
Wow. So it's gone from clueless newbie to Doom Master.
Uh-huh. Pretty much.
That's incredible. What are the key ingredients in this transformation? How did Geo actually teach the AI to become so skilled?
That's a great question. Let's dive into that in more detail. All right, so we've seen this incredible before and after, the AI going from zero to hero in Doom.
It's amazing.
Break it down for me. How did Juliel actually train the AI to become so good?
Okay, so first, there's the reward system we talked about.
Right.
The AI gets positive rewards for good actions, like defeating enemies or finding health packs.
Okay.
And negative rewards for bad actions,
Like
taking damage or dying.
Makes sense.
So it's learning through this constant feedback loop
Oh.
of rewards and penalties.
Right.
Figuring out what actions lead to success and what actions lead to failure.
Exactly. But it's not just about blindly chasing reward.
Right.
Jewel also talks about this important balance between exploration and exploitation.
Exploration versus exploitation.
Yeah.
What's the difference?
So exploration is all about trying new things,
Okay.
even if they might lead to failure.
Oh, interesting.
It's about the AI stepping outside its comfort zone
I see.
and experimenting with different actions to see what happens.
So it's like the AI being curious and adventurous,
Yeah.
not just sticking to what it already knows.
Precisely. But then there's exploitation,
Oh,
which
yeah.
is about using the knowledge the AI has already gained to make the best decisions possible. It's about capitalizing on the strategies that have already proven to be successful.
So it's like, it's a balancing act. The AI needs to be adventurous enough to explore new possibilities,
Yeah,
but also smart enough to exploit the knowledge it's already gained.
exactly. Finding the right balance between exploration and exploitation
Right.
is crucial for optimal learning.
If the AI explores too much,
Yeah,
it might waste time trying things that don't work.
it's exactly.
But if it exploits too much,
Uh-huh.
it might get stuck in a rut
Yeah.
and miss out on better strategies.
Makes sense.
It's like in real life,
Right.
you have to be willing to try new things,
Yeah.
but also learn from your past experiences.
Exactly. And then there's the whole tuning parameters thing that Juil mentions.
Okay.
Things like learning rate and batch size.
What are those?
These are essentially the knobs and dials
Yeah.
that you adjust to fine-tune the learning process.
Oh, so it's like fine-tuning a musical instrument
Yeah,
to get the best sound possible.
that's a great analogy. These parameters control how quickly and effectively the AI learns from its experiences.
I see.
Getting them just right can make a huge difference in the AI's performance.
And I bet none of this works without a ton of practice. Gilles talks about training the AI over thousands, even millions of episodes.
Absolutely. Reinforcement learning is all about learning through experience.
Right.
And the more experience the AI gets,
Yeah.
the better it becomes.
It's mind-blowing to think that by playing a video game over and over again,
I know, right?
an AI can learn to understand complex concepts
Yeah.
and develop sophisticated strategies. It's like it's developing its own form of intelligence.
It really is remarkable. And remember that Confucius quote we started with?
Yeah.
It's like this AI truly understands doom by doing it, by playing and learning through experience.
It's incredible to think how this type of learning could be applied beyond video games.
Yeah.
If AI can master a complex game like Doom, what other challenges could it tackle?
That's the exciting part. The possibilities are endless. From optimizing traffic flow to personalizing healthcare treatments, the potential applications of RL are vast and far-reaching.
This deep dive has been truly fascinating. Big thanks to Himant Juel for such a thought-provoking article.
Yeah, he did a great job.
And to you, our listener, we leave you with this. If AI can master Doom, what seemingly impossible task could it conquer next? We'd love to hear your thoughts. Until next time, keep exploring those technological frontiers.